Welcome to the DIY Honda Garage channel. The error code P0332 indicates a problem with the knock sensor 2, located in Bank 2 of the Honda Pilot models from 2016 to 2022. This code points to low voltage in the knock sensor circuit. The knock sensor's primary function is to detect engine knocking or pinging, which can be a sign of improper combustion. If the sensor does not operate effectively, it can alter the vehicle's ignition timing and fuel-air mixture, leading to performance issues. The knock sensor is usually positioned near the engine block, where it can best monitor vibrations caused by knocking. Understanding this error code is crucial for maintaining engine performance and reliability, as any malfunction can result in significant issues if left unaddressed. The DTC P0332 refers specifically to the knock sensor 2 located in Bank 2. The knock sensor plays an essential role by monitoring vibrations caused by engine knocking, which happens when combustion occurs in an uncontrolled manner. This sensor sends a voltage signal to the powertrain control module, PCM, indicating the presence of knocking. When the code indicates low voltage, it suggests that the signal being sent from the knock sensor to the PCM is weaker than expected, which could impede engine performance. Typically, this sensor is situated on the engine block, ensuring that it can accurately assess vibrations. Accessibility is also essential for diagnostics and repairs, making its location near the engine area vital. There are several potential causes for the DTC P0332, each of which must be thoroughly investigated. A defective knock sensor is the most common issue, where the component itself fails to send accurate signals. Wiring problems, such as frayed or broken wires, can lead to poor connections that disrupt the flow of voltage from the sensor to the PCM. Furthermore, issues in the powertrain control module, PCM, could also contribute to the low voltage condition, although this scenario is less frequent. If not diagnosed correctly, each potential cause could lead to serious engine performance problems. A proper understanding of each cause is essential for effective troubleshooting and resolution. The symptoms associated with DTC P0332 can manifest through several identifiable signs. The most noticeable symptom is typically the check engine light illuminating on the dashboard, which serves as an initial alert to the driver about a potential issue. Drivers may also experience poor engine performance, such as rough idling, reduced power, or decreased fuel efficiency, which can lead to frustrating driving experiences. Additionally, a noticeable knocking sound may occur if the engine is knocking, indicating uncontrolled combustion. Recognizing these symptoms promptly is crucial to prevent further damage to the engine, as neglecting them could lead to significant performance degradation and costly repairs. The first troubleshooting step for the DTC P0332 involves turning the vehicle to the on mode and utilizing the HDS or Honda Diagnostics system to clear the DTC. This action effectively resets the vehicle's computer systems and allows for a fresh diagnostic to be conducted. After clearing the code, it's important to turn the vehicle to the off mode, which helps to fully reset electronic systems. Subsequently, restarting the vehicle to the on mode enables the technician to check for any pending or confirmed DTCs using the HDS once again. This step is critical since it allows the technician to determine if the code reappears, helping to confirm the persistence of the issue. If DTC P0332 is present again, it indicates a more serious underlying problem that requires further investigation. In the second troubleshooting step, the technician begins by turning the vehicle to the off mode. This disconnection ensures safety while handling sensitive electrical components. The next vital action is to disconnect the knock sensor 2 connector. which involves locating the 2P connector for the sensor in bank 2. Once disconnected, the technician turns the vehicle back to the on mode to check for pending or confirmed DTCs using the HDS again. If the HDS indicates that DTC P0333, which refers to a high voltage condition for NOx sensor 2, is present, it confirms that the issue lies directly with the sensor itself. If DTC P0333 is not recorded, further troubleshooting steps will be necessary to locate the problem. The third troubleshooting step involves turning the vehicle to the off mode to ensure electrical safety. Following this, the technician will jump the SCS line using the Honda Diagnostic System. The SCS, or Service Check Connector, allows for diagnostic procedures without interference from the PCM. It's crucial to wait for more than 1 minute after jumping the SCS to ensure accurate monitoring of the electrical systems. Next, the technician disconnects the PCM connector C, specifically the 51P connector, to check for continuity between test points 1 and 2 on the NOx sensor 2 connector. Test point 1 is the first terminal, while test point 2 is the second terminal of the sensor connector. This step is imperative to determine whether there is a shorted wire in the KSB2 line leading from the PCM to the NOx sensor. If continuity is present, it confirms that there is an underlying short circuit issue that needs to be repaired. The final troubleshooting step involves checking for continuity between test points 1 and 2 under specified conditions. Here, the technician checks whether there is continuity from test point 1 on the NOx sensor 2 connector to the body ground. Performing this test requires the vehicle to be in off mode, and both the PCM and the NOx sensor 2 connector must be disconnected. If continuity is verified, it indicates that there is a short circuit in the KSB2/KSB2 wire leading from the PCM to the NOx sensor. The necessary repair would involve addressing this short to restore proper function. However, if no continuity is found, it suggests that the wiring is intact. At this point, the technician should check for any authorized service information related to the DTCs or consider substituting the PCM with a known good unit to rule out any PCM-related faults. After addressing the issues associated with DTC P0332, the final verification of repairs is crucial. First, the technician should recheck the DTC with the HDS to confirm that the previous error has been resolved and that no new faults have emerged. Following this verification, a test drive of the Honda Pilot is recommended to assess the overall performance of the vehicle. During the test drive, the technician should pay close attention to any symptoms that may arise, such as knocking sounds or poor performance. Finally, it is essential to monitor the vehicle's systems closely after completing the repairs to ensure that the issue does not recur. This verification step guarantees that the repairs made have effectively removed the fault and restored the proper functionality of the engine. Implementing preventive maintenance is essential to avoid future occurrences of DTC P0332. Regular inspections of the NOx sensor and its wiring can help detect potential issues before they become serious problems. Technicians should be vigilant about checking the integrity of wiring connected to the NOx sensor, ensuring that there are no frays or loose connections that could lead to low-voltage situations. Additionally, it is advisable to use original equipment manufacturer (OEM) parts during repairs or replacements to ensure that compatibility and quality are maintained. By following a consistent preventive maintenance schedule, vehicle owners can help ensure the longevity and reliability of their Honda Pilot. Focusing on these aspects not only improves performance, but also enhances user safety and satisfaction. In conclusion, understanding DTC P0332 and its implications is crucial for ensuring the health of your Honda Pilot's engine. Recognizing the symptoms early can lead to timely intervention and prevent significant damage to engine components. The knock sensor serves a vital role in managing engine performance, so issues related to it must be addressed swiftly. By following the systematic troubleshooting steps outlined above, technicians can identify and correct the root cause of the problem effectively. Employing preventive maintenance practices is equally important to ward off future issues. Keeping the vehicle in optimal condition not only enhances driving experience, but also safeguards against costly repairs in the long run. Please like and subscribe to the channel. See you next time.